was it on my phone?
Okay, this is from Macy and Dylan and Owen.
Right, I didn't
Okay.
know.
Derivatives, this is techniques of differentiation. This is mostly what's called the product rule, or power rule, sorry. Power rule is what we're learning today. And we talked about derivatives, okay, and this is like ways of finding derivatives, but we're gonna kind of take a little bit of a step back from like what a derivative actually means. Like, yes, it's the slope of a tangent line. Yes, it means velocity, all that stuff. There will be a couple story problems sprinkled in there, but like most of it is gonna be like using this rule or using this method to like shortcuts for derivative, right? We're not doing the limit process anymore. We're doing them really fast, okay? Using the stuff, okay? Now, they might ask for the derivative. They'll say, find the derivative, or they might say this word, differentiate. That means find the derivative. Differentiate means find the derivative. They might say find y prime. They might say find f prime of x. They might say find dy dx. All of those mean the same thing. That's just different verbiage that they will use to find the derivative. Got it? Okay? And these are all like shortcuts to finding those things. Good, good? Okay, here's your first shortcut. If I'm taking, so they use this notation, d over dx. This just means the derivative. The derivative of c, and c is a constant. What's a constant mean?
Any number.
Just a number. So if I'm taking the derivative of a number, like let's say y equals 2, and I want to find the derivative of 2. I already told you the way to cheat, or like the rule for it is x to the nth power, right? To find the derivative, you bring the n down in front, and it's x to the n minus 1, right? Okay? What's the x that's on here?
0.
This is x, this is like 2x to the 0 power, right? So if I apply this rule right here, 0 is going down in front, so 0 times 2x to the technically negative first power, but anything times 0 is going to knock that whole thing out. So it is 0. What they say right here with this rule is that the derivative of any constant is going to be 0. Yes? If it's 7, if it's 14, if it's 132, the derivative of that number, as long as there's no x behind it, is going to be 0 because it's x to the 0 power. 0 comes down in front, knocks the whole thing out. Got it? The derivative of a constant is 0 always.
Why is it d over dx and not dy over dx?
Because this is saying take the derivative, whereas dy dx is the result of that. Right? This is the result. They'll say find dy dx, or they might just say d dx means find the derivative.
So find dy dx
Yes.
from d dx.
Correct. Yes. It's just like what terminology they use, okay? All right, so, yeah. Another way of looking at this is like, let's say here is my function, y equals 2. Y equals 2 is a horizontal line, true? And they say, what is the derivative? Derivative means slope of the tangent line along this curve, right? Wherever I pick a point, what's the slope of that line going to be? 0, right? That's why a constant has a slope of their tangent line being 0. The derivative is 0 at a constant always because those tangent line's always going to be horizontal at those places. Got it? Got it? Okay, so example 1, they say the derivative of 1 is 0. The derivative of negative 3 is 0. The derivative of pi
0.
is 0 because pi is a number, not a variable, right? Okay? The derivative of negative square root of 2 is 0. No matter what, that number is gonna go away and be 0. Yes, sir.
Complex numbers?
What?
We won't be I don't think we ever take derivatives of complex numbers, actually.
Is that in math?
Like I is no longer a thing. We won't see i's in calculus. How sad.
Even in
won't
the
see
non-linear
eyes. You won't see eyes.
No.
How do you see without eyes?
No, I don't think we ever see imaginary numbers in calculus, actually. Yeah.
Dang it.
Thank God.
I'm trying to think if that's wrong, but I don't think we ever have imaginary numbers in calculus. I don't know.
What about Calc 4?
Calc 4? Are we for real?
Well, sometimes they have Calc 4s, yeah. Calc
I
4.
thought it was 1 through 3.
It's 1 through 3 at like Hastings College, but like universities, like UNL, they have Calc 1 through 4. They separate it out over 4 semesters instead of 3.
But isn't it?
But
like
it's
that?
2 years. 2 years of calculus.
It's like
So
1's easy, 2's difficult, 3's.
2 is the hardest. Well, at
Three's
least
a
it was at
little less
Hastings
hard
College.
than
I took it at
4.
Hastings College, and 2 was the hardest. 3 was the easiest. 1 was like the middle one. So
Why was 3 the easiest?
we will get through, hopefully, if we get to the same spot as we did last year and the last couple of years, we will get through probably the first half of Calc 2 stuff is where we will get to.
Calc
We will get through the first half of Calc 2 stuff. All right, moving on to the next one. Let's say we're taking the derivative of x values, right? The rule is x to the nth power is n x to the n minus 1. So if I'm taking the derivative of x, what's the exponent on x? 1. So the 1 comes down in front, right? This is 1x to the 1 minus 1, right? N minus 1, which would be 1x to the 0 power. And x to the 0 power is going to go away. So it's just going to be 1, right? You see how that follows this rule as well? Okay? So the derivative of x is 1. What is the derivative of, what's d dx of 4x? 4. What's d dx of negative 7x? Negative 7. Okay, Jacob just said it makes sense. Like if I graph y equals 4x, right? That's a linear function that has a slope of 4 all the way through, right? Negative 7x is a line that has a slope of negative 7 all the way through, right? That makes sense. If I pick a point on that line, it's going to be that, right? Got it? Okay, here is the actual power rule, right? I've been saying that all along. X to the nth is n, x to the n minus 1. So the derivative of x squared is 2x to the first power, yeah? The derivative of x cubed is 3x to the second power. Yeah? Do we see how this works? Now they're going to have us do it. So example 2. What's the derivative of x to the fourth power? 4x to the third. The derivative of x to the fifth? 5x to the fourth. Derivative of t to the 12th. Now they're just switching variables on it. 12t to the 11th, right? We get this? Yeah? Okay, what is the derivative of x to the pi? Pi?
Pi x to the pi minus 1.
Pi x to the pi minus 1. Yep.
No, sorry.
Okay, now they're going to really make us think a little bit. 1 over x.
It's like x.
Well, you flip it up.
Yeah. So instead of 1 over x, I'm going to move this guy to the top, and he's going to be x to the minus 1. That's what 1 over x is, right? Now let's apply the rule. So I do. Negative 1 comes down in front. X to the negative 2, but now I'm going to fix it.
Over x squared.
So this is negative 1 over x squared. Do you see how that works? Yeah. X to the minus 1 is what that would be to the top. Bring it down in front. Subtract 1. There's that, right? Okay, so this guy, if I rewrite it, w actually is my variable, not x, okay? This is w to the negative 100th power, right? Okay, so now if I take his derivative, negative 100, w to the negative, nope, you're subtracting 1. Negative 101, that gets people, okay? So if I fix it now, that is it's negative 100 over w to the 101. You see how that works? Okay? Yeah?
I suppose.
Okay, don't forget that when it's a negative exponent already, when you subtract 1, you're making that number bigger, right? Yeah? I mean, technically smaller, but like the number is bigger, right? Okay? All right, now we have x to the 4/5 power. Okay? It's positive 4/5. I don't have to do anything with him, right? But you're going to have this happen. So a fractional exponent. This guy means, just FYI, the 5th root of x to the 4th power, right? That's what the 4/5 power means. Okay, how do I find the derivative of that? 4/5 comes down in front, x to the, if I subtract 1 from 4/5.
3/5. Compromise.
Okay? 4/5 minus 1 would be 4/5 minus 5/5, right? Which is negative 1/5. Yeah? Okay, now how do I make that negative 1/5 positive 1/5?
Divide
So-
by
4 over 5, x to the 1/5, right? Now he's down on the bottom. Yeah? If I want to make him better, he is 4 over 5 and the 5th root of x, right? That's what he looks like. And we're not worrying about rationalizing exponents right now, or rationalizing fractions right now. So trig stuff doesn't apply because we get to leave square roots in the bottom. Okay? Got it?
Oh, I think.
Okay, let's do this one. What's the cubic root of x look like as a fractional exponent? X to the 1/3. Yeah.
You wouldn't move.
No.
Never mind.
Nope, we don't.
You wouldn't.
Okay? Nope, you're not moving.
No, it wouldn't.
1/3 x to the,
Great question.
if I subtract 1, what's 1/3 minus 1?
Negative 2.
Negative 2/3, right? Okay, now I'm going to put him back down to the bottom. So 1 over the 3 is going to be x to the 2/3, right?
Yeah.
And if I fix that, that is 1 over 3.
The cubic.
cubic roots of
Squared.
x squared. Okay, and you can put the 2 inside or outside. That's what he looks like. Woo, that was really fast. Are we doing okay? So, yes, it's very easy when you have stuff that looks like this. But when you start to have fractional exponents and all the things, that's when it gets a little bit trickier. All right, let's keep going. Let's go to example 4. Let's see if you can figure this out.
Easy peasy lemon.
Easy peasy. This one, 4x to the 8th power. What do I do if there's already a 4 there?
Multiply.
32x to the 7th. Yeah? Make sense? Okay. This one is negative 12x to the 11th. Yep, you got it. Okay, what about this one? Let's fix him first. D over dx of
X.
pi x to the negative first, right? I'm going to make that negative first. So they're both going up to the numerator, right? Like the pi's already in the numerator.
Negative
X is going up.
Negative pi over x squared.
Negative pi x to the negative 2, right?
But then
If I subtract 1. But now I've got to move him back down. So negative pi over x squared. You got it. Yeah?
Money
We can do
square.
it?
But what does money square equal?
Is this making sense a little bit? I feel like this is already going better than it was day 1 of last year.
Problem equal money square.
Okay.
But what does money
This is
square
going better
equal?
than learning derivatives of the first time.
No, it's
So long, yeah. Okay, let's go to example 5. What if I have 2 pieces?
Them together.
the limit equals
Do we do them
root of all.
You just do them separately, right? What's the derivative of this one?
Money.
What's the derivative of 2x to the 6th? 12x5? Okay. What about x to the negative 9th?
Problems equals money squared.
Negative 9.
Negative 9, x to the
Money squared. So
negative
equal the root of all problems.
10, right? If you subtract 1, right? Okay. Then we're going to fix him.
Yes.
So 12x to the 5th is going to chill, right? And then how do I fix this guy?
Plus.
Nope.
Minus.
Minus
Minus
9 over
X.
x to the 10th. Okay, now the x to the 10th only goes below the 9 and not below the whole thing, true?
Yeah.
Like this guy is just his own term. He's just chilling off to the side. This is what he will look like. Yeah?
Well, you can put them together.
I mean, you can, but it won't be negative 12, or it won't be 12x to the 5th then, right? You have to do a common denominator if you want to put them together, and we're not doing that. Okay? All right. You ready for this one? What in the heck? I am not going to take the derivative yet until I fix him.
Flip him upside down and do
Okay, I'm going to do this. I don't know if this is how your brain works, but I'm going to do this, okay? So let's just say this guy right here is x to the 1/2 power, true? Minus 2x to the 1st power. That's what that top is, right? Okay? This is x to the 1/2 power on the bottom, right? If I flip him to the top, it's as though I'm multiplying by x to the negative 1/2, right? If I flip him to the top.
Yeah, just cross
Yeah?
out the X.
Now, what do?
Cross them off.
I'm going to multiply him through.
Just cross them off.
Kind of. Okay? What is x to the 1/2 times x to the negative 1/2? What do you do with the exponents? You add them. So what's 1/2 and negative 1/2? X to the 0, right? X to the 0, which is 1. So that's going to be 1 in that spot, right? Okay? Minus 2, and what's x to the 1st and x to the negative 1/2?
What? I thought anything to the 0 exponents to 0.
Anything to the 0 is 0 power is 1.
Except for 0. Because, like,
Yeah.
Fine.
So what is this going to come out to be? 2x to the what?
Is it 1?
Yeah, what's 1 and negative 1/2 together added is just 1/2.
30.
Now, have we taken the derivative yet, though?
No.
That was just simplifying. We still have to take the derivative of that, d over dx of this thing, right? What is the derivative of 1?
Nothing.
This is like 1x to the 0 power, right? It is 0, right? Okay, now I'm going to take the derivative of negative 2x to the 1/2. So the 1/2 comes down in front.
Negative x.
Negative 1 x to the, I'm going to subtract 1 from the exponent,
Negative 1/2.
negative 1/2.
Yeah, put it on the
Was that too fast?
No.
Okay, now I'm going to put him on the bottom.
Always just, okay.
Yeah, and now I'm going to put him on the bottom. So 0 just goes away. I'm just going to ignore the 0. Negative 1 over
X to the half.
x to the 1/2, or negative 1 over
Square root.
the square root of x. Beautiful. Look at that. Yeah. Woo! Psh. Let's do example 6 and we'll stop. Yeah? 6. Okay? This one has how many terms? 4. Let's find the derivative of him. So what's the derivative of 3x to the 8th?
24x
24x to the 7th minus.
10x to the 4th.
Correct? Plus
1. 6.
6, because this is to the first, right?
X is 0.
Plus
0.
0. The 1 goes away, right? Okay? And I'm going to label that as y prime, or they call it dy dx, right? That's derivative of y with respect to x, okay? dy dx, y prime, all of those mean the same thing, but this is the derivative. Yeah, yeah? Not too bad. All right, we're doing all right.
So do we have to do anything with that or
No, they just said find dy dx. That's what it is, right? If they say find dy dx at x equals 3, we would plug 3 in, right? Okay, that's what we're going to have us do in this next one. Well, not quite, okay? But I don't want to get to example 7 yet. But homework is, let me write it down. And we're about to the end, so that's exciting. Homework, you can start on it. It is page
14.
I don't think you're right. Calculus, page, this is 2, 3, 106.
Sigma boy.
2 through 10 evens,
Sigma boy.
106.
106. 2 through 10 evens, 18, 40, and 64.
Quit
18.
graffiti on my.
18, 40, 64. I think you can probably do 2 through 10 the evens. I think 18, 40, 64 are probably going to be like the end problems.
No, I wasn't there. 'cause we were
Okay.
all saying you stupid ass.
There he is. There he is. Okay.
We can do all of this.
I think you can do all of 2 through 10 evens, but not 18, 40, 64. You can look, but I think 2 through 10 evens are fine. We'll finish the notes tomorrow. Not tomorrow, because we're taking the probe test tomorrow.
Finish it whenever.
I'm gonna.
Yeah, so Dylan and Owen, we are taking the probe test tomorrow. I don't know, Dylan's probably going to be gone though, right? So Dylan will take the probe test on Thursday. That UNL test that I was kind of maybe warning some of you of, we're taking that tomorrow during calculus. Okay, I'll explain the rules again tomorrow, but that's what we will plan on. All right, we'll come back to this on Friday, whatever. Yeah.
Oh, at least you know, like, state,
Okay, goodbye.
because we don't have it.